Hello, hello, everyone. Welcome. It's Wednesday. It's Catalog and Cocktails. It's our weekly live hangout that's an honest, no BS, non-salesy conversation about enterprise data management with tasty beverages in hand and sometimes nice clothes as well, although not always. I'm Tim Gasper, longtime data nerd and product guy at data.world, joined by my co-host Juan.
Good afternoon. I'm Juan Sequeda, the principal scientist at data.world, and we've been, for the last 5 minutes behind the scenes preparing our drinks, or actually watching our guest, Sam Bale, prepare her drink and getting all dressed up for today. So for folks who are listening to us on the podcast, you can actually see us if you wanted to on YouTube. I don't know if you want to, but anyways, I'm thrilled to be here also with Sam. Sam is from Superconductive, the company behind the open source data testing tool called Great Expectations. Sam, great to have you here. Finally.
Hello. Thanks for having me. Third time's a charm.
Here we are. Yeah, we've been trying to get Sam here, and finally we made it happen. So I'm really excited about this. Just a couple of quick reminders. We have a new website. You can go to data.world/podcasts, and you can find all in one place, all our past podcasts, and you can see the schedules of who are our next guests. So we're really excited about that. And you can sign up live to watch. You sign up so you can join us live. You can also, for everyone who's listening to our podcast and everybody who's here right now, please go to Apple Podcasts, go rate and review us, and you can follow us on Spotify and everything. And for our podcast listeners, reminder that you can always join us live every Wednesday at 4 p.m. That's when we do this live, and then we stop the recording at 4:30 Central. And after that, the after party starts, and we have all these discussions. We also have our Slack community. You can go to slack.data.world and join us on the Catalog and Cocktails channels. We always share our takeaways. So with that, the first question always, what are we all drinking today? Sam, you go first. Because we watched you like for 8 minutes. It took you 8 minutes to make that drink. I counted.
Half of that was cleaning, like finding a clean glass and falling over the dog. So I am drinking a Negroni today. It is not a classic Negroni. I've changed up the ratio a little bit. So classic Negroni would be 1-1-1 gin, vermouth, and Campari. That's a little too sweet for me, so I usually just go double on the gin. Cheers.
Nice.
Cheers.
I love my Campari, so I salute you on that. I'm drinking a whiskey mule. I've been doing some vodka mules lately and decided to change it up a little bit, and it's using an extra spicy ginger syrup. So I like my spicy ginger.
And then I got my family from Mexico is here, and I have a Smirnoff spicy tamarind infused vodka. This is so good, and put it in a little bit of squirt, and that's my drink right now. So hey,
this is going to sound ignorant for a second. Is tamarind like a fruit or something?
Yeah, tamarindo, tamarind. That's a fruit.
Okay.
So cheers. What are we toasting for? What are we toasting for? Sam, what are you toasting for?
I am toasting for, I don't know, haven't finally made a Wednesday without insurrections to do this podcast recording. I think that's an accomplishment, having made it through the inauguration, which was the backup date, which we also had to cancel. So yeah, I think I'm toasting to having finally made it onto this podcast. I'm very excited.
We're glad to have you. How about you, Tim?
I will toast to just this whole interaction makes me wish that we could all be hanging out in person again. Cheers to one day being able to all hang out again and have drinks in person.
I'm going to do that same thing. I miss interacting with people. So cheers for that day to come back soon. So, and so we got a quick question, an icebreaker here. Who received the highest SAT score? That was the question I was asked to ask her.
That's the question?
Yeah. I'm going to tell her. Man. So I'll be honest, I didn't finish my high school in the US, so I didn't do an SAT, so I can say I don't have one.
Opting out.
Well, that makes two, because I'm not from the US. I'm from Germany originally, so I also don't have an SAT score.
All right. So actually, done. Tim, you win. You got the highest SAT.
Mine was a 1600. I just want to say it was perfect. I got into MIT, but I told him I wasn't interested, just in case y'all wanted to know.
All right.
Just
Well,
kidding.
post in the chat. Tell us where you're coming from. What are you drinking? What are you toasting for? And what was your SAT score? If you want to go share that. But so, all right, let's go kick this off. Let's go. We talk about people, processes, technology, and we got to talk about culture. And I think something that puts this all together is data testing. And I have to say, I encountered Great Expectations fairly recently, and I was super excited. Actually, I saw, Sam, your talk at the Coalesce, the DBT conference.
Mm-hmm.
And I'm like, oh, this is music to my ears, everything we're doing, because we talk always about why don't we treat data like software, and we do testing for software. Where is this? So let's chat first. What does data testing actually mean? Because we hear these terms, data testing, data observability is a new one that we were seeing. Like our friends from Monte Carlo Data just raised a bunch of money. They're starting to go push a lot there. There's data profiling, data quality. Like, let's start demystifying all this stuff. So let me just throw it to you, Sam. What do you define as data testing?
Yeah, this is really funny because I think I will just be kind of stating the obvious. It's like data testing is one of those things that everyone knows they should be doing, and it sort of just like never bubbles up to the top as a priority in like in an organization, and until something bad happens. It's kind of like that. It's like, yeah, I should be exercising, or I should be, eating healthier. It's like data testing is exactly like that. So my definition of data testing is basically, and oh my God, I'm just coming in hot with the cliches here. We all know about garbage in, garbage out, right? So if you have any kind of data analysis in your organization, if you make decisions based on data, if data has any kind of relevance in your organization, which it probably does, you want to make sure that any kinds of conclusions you draw from your data are actually correct, because the data is correct. Or let's put it the other way around. You might want to make sure that your conclusions aren't wrong just because the data is wrong. You might still misinterpret your conclusions or your data, obviously. Like, you might still do completely crazy things with that, but you at least want to know that this is not because your data was complete garbage. So one example is actually, this is like one of my favorite examples is when you have survey data, for example, for like market research, and usually if you have answers coded as, let's say, yes and no, as like 1 and 2 or 0 and 1 or whatever it is, occasionally organizations or data teams just like assume like, oh, yes is always 1 and no is always 2. But you might also just go with like standard Booleans. So 1 is yes and 0 is no, or whatever it is. So depending on how that kind of data changes, your analysis that you do on whether someone responded yes or no might just be completely wrong, right? And those are the things. So data always changes, and you're kind of making an assumption about it. And so data testing is basically just making sure that the thing that you expect to happen, and I'm going to also make a lot of expectation puns and wordplays today. The basic data testing just means like, what you expect from your data, you have certain expectations or certain assumptions, and you ensure you assert that these actually hold true, in order to, again, like make sure that the conclusions you draw from your data aren't just wrong because your data is garbage.
Yeah. I think it's the sign of a good product name or company name when you can use lots of puns. That means it's a good name great choice. Yeah, I think that's a great framing and great definition. And, in software development, right, we hear all the time like, test-driven development. You got write your unit tests, write your integration tests, write your deployment tests, right? Like, why isn't that more popular in the data world? And who should be doing that?
Yeah, like I said, data testing is kind of the thing everyone knows they probably should be doing, and they kind of like, have felt the pain before of, having to rerun a pipeline or having to rerun an analysis because something was botched. So this is totally my personal sort of experience or personal interpretation of the situation. I think traditionally data teams are further sort of removed from the software engineering process, and like getting testing to be sort of like standard in software engineering took a while, right? And even now there's a lot of companies and a lot of software teams out there that kind of know they should be writing tests, but you know what? It's easier and quicker to just like launch that thing and deploy it. And yeah, we'll write the tests later, and then it just doesn't happen, right? So in software engineering, at least now, it's sort of like the thing to do, and people understand that this is like you can't launch software without having unit tests running, having continuous integration, continuous deployment. So right now, it's just sort of been drilled into our heads for such a long time, or for long enough, that it's pretty standard. I think in data, because like I said, a lot of data teams kind of come from a non-engineering background, right? There's a lot of statistics people, a lot of people who started out doing Excel spreadsheet analysis, and then maybe write a little bit of SQL, things like that, right? So those teams are often not integrated into the software engineering process and workflows, and are just kind of removed from that and don't necessarily have the right tools to do that. So even like, here's a funny example, and I hope no one at my former company takes this personally, but like even at a company that I was at previously that was doing healthcare data analysis, where we hired very, very strong, amazing software engineers with a lot of experience and everything. We also had a data team, which was mostly statisticians, who did not do version control on their code, on their analyses. And it didn't, like, the test they were doing was really just running things manually and like looking at results, and there wasn't anything automated. So it was actually really funny to see sort of the gap between software engineering, the best practices, and having like extremely well tested like applications, and then having the data team just kind of doing everything manually, and you just look at it as like, oh my god, you poor people, like let us help you. Let us figure out
they've been
like,
left
how
out,
we can
right?
automate the processes.
So this is interesting.
It's really like this.
I always ask, like, why do data teams not test their data, do all this stuff? And I ask why, and you just gave the answer, or gave an answer, which is because the people who are
answer for sure.
People who are there, they actually don't have that background in software, right? They're just, they traditionally have been looking at Excel spreadsheets and so forth, right? So they're not trained to go do that. So what is an ideal data team look like? And I'm going to just postulate here that it looks like we should have your product managers who have a software background, who want to go, who make a transition into data. Like, those are the folks who should be actually setting the bar of how we should go do this, and educating the rest of the data folks. Hey, we got to go do these types of stuff that you probably have no idea about. You're going to go learn this right now. I think this falls into, again, comes back always to this whole data product management team that we need to go do. So I think that's one of the takeaways I'm getting here right now. I really like this. We got to basically, you got to have a product. You have to have your product, somebody who has a software engineering background, and put them in the data team. It's not just data people.
Yeah, absolutely. Totally agree. I think pairing up, I think in order to have a sort of data A team, you do need to have software engineering best practices on that team, and you need to have someone who can help implement that. I'm not saying that like in a meme kind of way, like, oh, those data people, they don't know anything, right? It's just not what they're trained to do, and that's totally fine. But if you are building up a data team and you want to make sure that your data isn't complete garbage, and your data team is not just that you're firefighting all the time because something went wrong, or they're spending a ton of time just doing manual analyses and looking at numbers and looking at dashboards and comparing like data next to each other, whatever it is they're doing, right? Like, you have to like build up a like really powerful sort of self-sufficient data team that can automate those kinds of processes.
Yeah, that makes a lot of sense. We've been hearing a lot lately about this sort of data ops concept, right? And kind of taking the practices of sort of DevOps and like code as configuration, or configuration as code, these types of approaches, and applying that to the data world. Is this sort of trend, is this movement contributing a lot to sort of data testing becoming more popular? You look at tools like DBT, for example, growing in popularity. I know Great Expectations maybe falls in this category. What's your perspective on sort of that trend, and how tools like Great Expectations fit in?
Yeah, I think this is it's always really funny to me. I just had this conversation recently with a friend, and who's also in a data role and doesn't have like a classic software engineering background. And she explained like all the issues she has in her organization with the data, like, oh, the data is coming from so many different sources and it's so hard to query across all the different places. And there's always some issues with it. And I told her, yeah, that is perfectly normal. Like that's usually how data works. And again, like this is sort of a personal opinion, personal impression. I think this is because the whole, that's sort of the weird gap for me. The whole like data engineering, data ops, data, like treating data as like an important thing is sort of new, even though it's not, right? Like data-driven decision-making has been like, I think for forever and ever and ever, but for some reason, like it's only just, and I think this might have also been with like the rise of machine learning in like the past 5 years or something, 10 years, right? That machine learning, like everyone can like deploy some algorithms and some library and has like their predictive models or something without knowing a ton. And I think that like has led to an explosion of like a data ecosystem really in the past. And I honestly, I would say like 5 years probably, right? Like, I don't know if anything about data like 10 years ago, what was there? Tableau maybe, a bunch of relational databases, a bunch of like NoSQL databases. I don't know, NoSQL was like the hot thing like 10, 15 years ago. But like this whole ecosystem of dbt, Airflow, Great Expectations, all the other data quality platforms and stuff, that's only just like exploded, right?
Well, it's like data engineering and data pipelining, right? It's really exploded.
Yeah. It's also because
exactly
we're seeing the whole rise of like self-service over the last 10 years or so, right? That now we talk about democratizing data, but really what we have been doing is democratizing the tools so people can go do stuff with the data. Think about it. I mean, we've been doing pipelines forever, right? Or data warehouses in the 90s. Like people were doing stuff. People were writing code, but that was a small group of elite folks who were doing that. So yeah, it's okay if it's 4 of us writing code and we're literally in the same room, like it's okay if we don't have version control. Of course we should, but it's okay. World's not going to go, everything's going to, nothing's going to break that much. We can go fix it. We are talking to each other or something, right? But then that's always been at this elite. And now over time, right, people are getting this more self-service stuff and I want to go do things on my own. And now suddenly you got more people interacting with data. So we've kind of gone from like one side of the spectrum and we've thought about it. Let's go as fast as we can to the other side of the spectrum. And we've missed a lot of these things. And I think just running so fast, we've tripped, we kept going. And I think now we're more and more people are falling down and we're like, wait a minute, let's go see what's going on here. So I mean, that's my interpretation of history here a bit. I want to go, you said something about dbt and Airflow and Great Expectations. What is an ideal kind of, call it workflows or tools coming together to do a pipeline to go from start to finish right now? Yeah. How do you see that? Where does Great Expectations? And by the way, you haven't even really introduced Great Expectations. So please.
Oh yeah. Let me talk about Great Expectations quickly. I haven't even introduced myself. So Great Expectations is an open source data validation tool. So it's written in Python. It's an open source library. And you can basically, it's pretty straightforward. It allows you to just specify what you expect from your data by just writing almost like assertions in Python. So you can have an expectation that says, expect column values to not be null, and then pass in your column as an argument, right? Or expect column values to be between. And then it gets like pretty exotic. So you can have KL divergence of a column. So in terms of distribution of value sets or values in value sets, you can have expect column to match regex, expect column we recently had someone implement an expectation that said expect column to be a valid zip code within a geolocation within a specific area. So the cool thing about Great Expectations, I have to give it a quick plug. We recently launched a new version that has what we call Modular Expectation. It basically just allows everyone to very quickly and easily write any expectation they want. So we had a few hackathons. We had some implemented expectation to test that a column, like all the values in the column are in a specific language, for example, just importing a Python library that determines that it's like a pre-trained model that determines the language in text. So things like that. The cool thing is you also have sliders, so you can define a threshold. So not like 100% of the values have to match your expectation, but maybe you can say just 90% or 80%, things like that. So just going back to your original question about sort of the ideal stack, that I kind of pretend I have a strong opinion, just because I really like the acronym we came up with, which is DAG, DBT, Airflow, Great Expectation. But I don't actually have a particularly strong opinion as to like whether this is really the perfect stack or not. It's just the one that makes the most sense to me right now. So for those who don't know, DBT is it stands for data build tool. It's everything is a DAG. It lets you build transformations. So DBT is basically the transformation step in your pipeline. So you can just write SQL, templated SQL, and can create a sort of dependency graph of your transformation pipeline. Airflow is a workflow orchestration tool. So instead of, I always call it like a glamified cron job. So it kind of is. It's like a shell, basically, like a fancy wrapper around cron jobs that just lets you schedule things and have dependencies. And then Great Expectations fits in there with the data testing. So the DAG stack that I tend to talk about a lot is DBT. So you do your transformation DBT. You coordinate or orchestrate any steps outside your transformation. So any kind of loading, any kind of downloading your files from S3 every night or every week or whatever, and then uploading it to your production database to power your dashboards and like refreshing your dashboard. So whatever it is that you can do in Airflow. So you have just Python tasks in Airflow, for example, or just bash scripts that do stuff. And then Great Expectations would be your data validation step, right? So at any point in your pipeline, you can say, okay, I've done a transformation. Like I want to make sure this data actually looks the way I expected. You can even do your testing like on the source data. So like run it against the files in S3. And if those S3 files don't look good, like don't even bother running your transformations, for example. So that's sort of like the combination that I really like. But obviously there are a lot of other things out there to basically do the same thing, but it's sort of the combination of doing a transformation thing, having your workflow orchestration tool to do other stuff, and then having some component of data testing in there.
That makes sense. So it sounds like you can kind of have this data testing step at a lot of different parts of the data pipeline, right? It can make sense to do it very early, can do it in the middle, do it towards the end to make sure that the final sort of data products are the way that you expect. Who's responsible for what in this kind of process, right? Is this all the domain of the data engineer? Is the analyst involved? Are there data quality people involved? What does the process look like, and what does the responsibility kind of look like?
I swear we did not discuss the questions up front, but I love that question. This is fantastic. So this is great because I actually wrote a blog post about it that kind of says like, okay, so you can write your tests, right? You can have your tests run, but that's not the important thing. The important thing about I call it a data quality strategy. Like the important thing about your data quality strategy is like, what the hell do you do when someone actually has to respond to that test, right? Like who owns responding to any kind of alerts, any kind of test failures, who owns maintaining those tests, updating them, right? Your job is not done once you've implemented some tests. Like that's where the real work actually starts. I do think it really depends. Like the answer is it depends. It really depends based on like what step in the pipeline you're at, and what the response would be, based on what thing is failing. So one example that we've heard from a bunch of users of Great Expectations, the team at Heineken and some other company, can't remember, but we have some case studies online actually. They have an uploader tool. So they use basically implemented data testing into their data upload tool because they've previously had data producers from all the different suppliers of Heineken. I'm probably butchering this, but bear with me. From all the different suppliers of Heineken, they basically had them upload, I think, just CSV files to FTP servers, and then the data engineering team would process these. And they'd always run into issues with that and had to go back to the data producers and say, hey, can you guys fix this? So they just built a data upload tool that has great expectations under the hood for data validation. And now every time someone uploads a file that doesn't match the expectations, they get the error and they have to fix it. So it's actually kind of fantastic because that also relieves the data engineering team or data platform team or whatever you want to call it from some of the debugging work from some of the, you have to fix everything.
Is that
right? And I think.
No, I was gonna say that seems like is that like the ideal thing? If you had to go with best practices, push the expectations as early as possible. So, or do you want to do that later? Or does it? Or depends. It seems to me that you want. I'm looking here in the chat right now. Shane says data ops equals you build it, you own it, you manage it. In a way, I would say, hey, if you upload it, I'm going to tell you immediately that this is wrong because don't send me crappy data. Like it's your fault. You go figure it out. Yeah. Anyways, I wonder where would that go? Where do you do the expectations part?
Yeah, I keep saying like test your data as much as possible, right? And as much as reasonable. Obviously, there's always performance concerns, and again, like ownership has to be clear. But there's nothing to stop you from testing the source data that someone uploads, right? And there's a job running, and it tells the people who upload the data, hey, this is not working, like go fix it. There is also an option to actually test your code. This is actually something I haven't mentioned yet. So the fun thing about data testing is that you're not just testing the data, but you're also testing the code that creates the data or transforms the data, right? So you have kind of the two, and that's what makes it different from testing software usually, because software, like you're basically just testing the code and you have some test fixtures. With data, if you have transformation pipelines, you're both testing whether your transformation pipelines, your transformation code, your SQL or Pandas or whatever it is, does the right thing. And at the same time, you're also testing whether the data that is being integrated from a third party or from some other team, whether the data is right. So you have actually two degrees of freedom that makes it significantly more complex. So if we're looking at the code, like the data transformation code layer, you can also test that code, right? And that's actually where you could, for example, run your test against fixtures to just make sure that whenever you change the data code, you're not like the result is still what you expect it to be, right? So that would be another stage where you could test, is actually testing your data transformation code. And then so one interesting thing when we talk about the ML models, for example, you could test basically your input data that's coming into the model to make sure like the distribution of values, for example, is around the same that you'd expect, to make sure your model actually, your production data matches the training data in some dimensions that are relevant. And then you can actually test, after the model has run, to also make sure the output still makes sense, because someone might have like fudged the model code, right? So there's just so many different
The answer
places.
is everywhere.
Everywhere. I think our motto, this is the Great Expectation sort of slogan, is like test whenever data changes hands, like whenever data kind of crosses boundaries between teams, right? When you're done with like a transformation, or when you're done with like an upload, or when you're done with running an ML model, right? Like at any point where sort of the data is being transformed or changed or moved, uploaded, actually physically moved, whatever, that's kind of a good place to make sure stuff didn't go wrong.
So I know that we're starting to run out of time here, so I think we have a few final questions, and I know we've got some interesting chats happening here, which is going to make for some great discussions after we're done with the show here. If people want to get started, Sam, what would be your recommendation on getting started and the right best practices to really get off on the right foot?
And by the way, like we keep we're very solid on our honest, no BS, non-salesy conversation. I'm just so excited about Great Expectation because it is an open source tool, right? This is open.
It's open source. I'm not selling anything.
So I just want to make that clear. But no, yeah,
you can buy me pizza if you want.
All right, no, but to Tim's question, I love this. So that key question, how do you start?
Getting started with data testing in general, Great Expectation specifically. Okay. Well, I think so. One way, and that's also like the going back to what I mentioned about like, just implementing the tests doesn't actually solve the problem. You have to like do it well. One way to start is really just think about the last time your data broke and something bad happened, right? And then just implement a test to make sure that doesn't happen again. So that's kind of usually my favorite starting point of iterate on that, make sure that thing doesn't happen. And again, like just going back to the case studies that we have with many teams, that's kind of how a lot of teams just start doing is like, oh yeah, we have this one breakage because of X, and we built a test to make sure X doesn't happen. Ideally, you'd want to, and this is one we're both from like the semantic web community, so we've probably talked a lot about knowledge elicitation in the past. So I also love to throw that term around because it's so lovely. So knowledge elicitation basically just means sitting with domain experts and kind of just like talking to them and asking, so, I'm looking at this fish data. Like, what are sort of some of the parameters that I should be aware of? Like, what's the heaviest those fish can get? Or what's like the coldest temperature that like I should expect in this column of like their habitat, right? Like things like that, where you kind of just like sit with experts, and there's also different techniques to sort of elicit some knowledge about the data, and then you start encoding that in your tests. I come from a healthcare like domain. That was my previous company, and that's exactly what we did with some of the nurse practitioners, some of the oncologists that were in staff. Is like, okay, should like this drug that's being given, like, should this be like, what's the maximum dosage anyone should reasonably be getting, right? And that's kind of where you start sort of building guardrails around your data.
Well, this is the work that I call the knowledge scientist should be doing, right? It's the knowledge engineer 2.0, right? They're asking these questions, right? Because you're talking to the end user, the business user, right? The domain expert getting that knowledge. I'm like, oh, let me go translate that and bring it to the data to make sure the data comes out right. So
absolutely,
and it's
so
iterative. Don't boil the ocean.
And that's one of the wonderful things of working with data. If you get to work with domain experts, with subject matter experts, and you show them some data and they take one look at it and they say, no, this is wrong, right? Like that's a fantastic, like, make use of your domain experts to write your tests. Like, the reason why you have domain experts on your team or on staff is because they know that stuff better than you do.
All right, I told you, Sam, 30 minutes fly by, and here we are to the end. We always like to close with some takeaways. So, Tim, you start with your takeaways.
Yeah, man, I got so many takeaways. I have to pick the best ones here. I love what you just said, Sam. The reason why you have domain experts on your staff is because they know better than you do. I feel like that's something we don't take advantage of enough. I have lots of conversations with data people, and they spend hours sometimes being like, well, I wonder if this is the right data or the wrong data. Well, did you ask the end user, right? Or the domain expert? You can just Slack them, And then, how to start, the last time something broke, start there, be iterative. I love that. So, I think that approach aligns so much with what especially Juan and I talk about when we talk about being agile, don't boil the ocean. Makes total sense.
Yeah, well, my takeaways here is on the data teams, we need to have folks from software engineering to go really kind of educate on how we need to go do this. We complained that why don't we treat data like software roles, because the data people actually don't know how to go build software probably. And that's okay. So let's go bring the software engineering expertise into it. And also what you just said about the knowledge elicitation, I think that's key, is that also needs to be part of your data team, right? Goes back to go talking to your end users. You also said something spot on. Data testing is not just about testing the data. but it's also testing the code that generates the data. I think that for me was the number one takeaway from this. And test is, do you test in the beginning, the middle, the end? Test when the data crosses boundaries. Another great point. Sam, thank you so much. And I told you we're going to ask 2 final questions. One is, what's your advice? Very broad. What's your advice in general? It could be about data, it could be about life, whatever. And the other one is, who should we invite next to Cataloging Cocktails?
Oh my God. Okay. So I thought a lot about like advice, and the thing that's like top of my mind right now is, if you're biking in wet weather, make sure you know what kind of brakes and what kind of rims you have, because steel rims and bad brake pads do not brake at all in wet conditions. That's my advice. Be aware of that if you're biking this winter. And I'm saying that because at least in New York City, the number of bikers has increased massively during 2020. And I'm sure there's a lot of new bikers who are not aware of that. So steel rims, danger zone. That's my advice. And who should we invite next? I think so. One of my favorite people that I've been working with here in New York City is Reshma Sheikh. She runs the Women in Machine Learning and Data Science group. She runs Data Umbrella. She's involved in PyLady, so she runs a lot of amazing events. She has decades of data experience, and she's also just generally a wonderful and very, very thoughtful person. She's kind of the yin to my yang. She's absolutely great person to work with. So I think it might be worth inviting her.
Awesome. Sam, thank you so much. It was a fantastic conversation, and looking forward to the after party now. Tim, Sam, have a great one.
Cheers.
Thank you.
Thanks, Sam, for joining us.